My name is Hideki and I'm from Tokyo. So today I'm gonna talk about a project I'm working on in the past a year or so called Marsface project. And yes, this is sci-fi track, but my talk is like sci-fi talk. So my talk is quite different from others, so hope you enjoy it. So we are Marsface project. We have a Facebook account, so @Marsface project, so please follow us. And so we are a group of both hardware and software engineers, researchers, and maker, writer, or artist, and also a robot in the middle. And so our project was launched as a part of International Space Apps Challenge organized by NASA. So how many of you know Space Apps Challenge? Yeah, he came from Japan. And so it's basically it's a 2-day hackathon for the space exploration. So you can build something interesting with space stuff. And so it seems like there's no event in Taipei this year, so hope someone in this room will organize the event next year. And let me introduce a little bit about myself and Python community in Japan. So I'm an optical design engineer. So my background is in physics, especially optics, and I design and develop lenses for digital cameras or other applications. I'm also passionate about photography. So I used to travel around Asian countries to take pictures of people, like these pictures. And I'm also an organizer of PyData.Tokyo, which we started last year. And we organize monthly tutorials or meetups in Tokyo. And we have now 700 plus members, and community is growing so fast. So these are the Twitter account of the organizers of PyData.Tokyo, including myself. And we have a great venue sponsored by the Japanese automotive company Denso, and so you can enjoy the great view of Tokyo outside, and so there's a ping pong table, so you can enjoy it if you want to join it. And also, I want to share that the PyData Okinawa was just launched. That is the second PyData meetup group in Japan, and the organizer is here in this room as well. And so the Okinawa is really close to Taiwan, and and so if you ever come to Tokyo or Okinawa, so please let us know so that we can show you around or find something interesting with Python or data. And also this obviously this gives you a great opportunity to come visit Tokyo. That is PyCon JP 2015. That will be held in October this year. And now the CFP is open until July 15th, so don't miss it. Okay, this is the end of my advertisement. And so back to the main topic. So what is Marsface project? Back in 1976, NASA's Viking spacecraft discovered the face of Mars. So how many of you knows that? A few? Okay. But later, in 2001, the face of Mars turned out to be an optical illusion like this. However, some people think it is evidence of life on Mars that NASA would rather hide, and that became a pop icon of the evidence of life on Mars, and appeared in the magazines or books or movies, and people are still looking for this kind of object on Mars. And as space exploration has been a great passion for a lot of people, and the outstanding progress of the technology is going to give us a lot of pictures in the future. We came up with the idea of finding these kind of structures. We call it pseudo-artificial structures by using a state-of-art artificial intelligence technology. And we applied two detection techniques, and so these are Marsface detector and Mars object detector. And more importantly, we would like to build something more interesting with these stuff. So I'm going to show you these as well today. And so obviously, a lot of satellite images are needed. But fortunately, 19,000 space images are available for free on the website of NASA. So we downloaded all images, of course, by using Python. And also, you can imagine that, so we need some computational power to analyze all of these images. And that was the issue for us last year, the beginning of last year. But later last year, we got a Microsoft Azure Research Award, and they offered us these cloud platform, including 32 compute instances, and also 10 terabytes of storage. That's too much actually, but and which the estimated total market value is like 40,000 US dollars. And so our analysis was mostly done on the Azure platform. So okay, so how Marsface detector works? So this Marsface detector was deeply influenced by the previous research by one of our members, Kurihara-san, called Geoface project. And he tried to find a lot of face-like structures on Google Maps. And for the EC 2010, that stands for entertainment computing. And that's actually a big conference. That's the most, I think, the famous conference for the entertainment computing field. And so he applied a face detection technique with haar-like features, which is very simple. And so I'm not gonna explain the detail, but this is easily, you can use this easily with OpenCV-Python bindings. And so the easiest way to install this is to use Anaconda, but OpenCV doesn't come with the Anaconda by default, so use the conda command, like conda install OpenCV, so you can just use it. And like some parameter tuning is needed to apply these techniques for the satellite images. And so I did it, and it works well for the face on Mars, like this. But we had a problem, like we also got a lot of false positives for that. That's the biggest issue we have now. That's okay. Like so we have to check all images, all detected images, to find out which image is more fun. It's hard to define our how can I say, like our thinking of which is more interesting for me, for us, like, and so we call it human computing, but this is the important part of our project as well. And so we apply these techniques to the all images, and finally we found this alien-like object on Mars. And so distance between eyes is like 3 kilometers, which is quite big. And so we felt like this is not only this is important not only for us but also for mankind. So we put these findings on the Wikipedia, so you can find it on Wikipedia. So there's a 3D imaginary here. So just so go to Google and find it. So face on moon south pole, and we want to do more than that. So we create the candies, and we call it space souvenirs. So the idea is if you go to the space travel in the future, the space souvenirs are needed. So we created and do you want some? Do you want to try to create it or not? No? So good news is that the 3D printed mode is available on the 3D printed shop shop in on dmm.com. It's a Japanese shop, but so there are a lot of materials to choose from. This is an expensive one. If you choose gold, it's about 10,000 US dollars. It's so expensive. But you can find cheaper the mode. And also we tried other algorithms to find these objects. One is library called LibCCV. It has the self-based detector, and so we found these faces as well. And yes, and this is my thinking. Like if you use the more sophisticated algorithms, you can reduce the false positives. But the detected face is like human, so that's not interesting for us. So it's difficult, but so I feel like sometimes the simple algorithms are better for our project, so that we can find more alien-like object. But the issue is that number of false positives are increasing. So if you have some ideas to resolve these problems, please let me know later or at today's party. Okay, that's the end of the explanation of the Mars face detector. And now I'm going to talk about the Mars object detector. And we used deep learning algorithm to find the face object, different object. The idea is that so if you use the face detector, you can just find face or alien-like object. But if you use the deep learning, you can find different kinds of object with one algorithms. So that's the idea. And so I'm not gonna explain the detail of the deep learning, but so do you know Kago? How many of you know Kago? Neko? No, Neko is a cat, right? The Kago is a website for the data scientists, and they offer the competition to solve something related to the data. And this is the one competition from Kago, which is to create an algorithm to distinguish dogs from cats. It's quite simple, right? And I joined this this competition, and I was surprised by this result. Top Kagras, all of top Kagras uses deep learning, and the accuracy is like top Kagura got 99% accuracy on that, which is amazing. So so after I joined this competition, I decided to use this to the Marsface project. And this is the most famous result by using the deep learning. So in 2010, so this is so another competition, the biggest competition for the visual recognition in the world, and called ImageNet Large Scale Visual Recognition Challenge. And as you can see, in 2010, one team called Supervision, which include the famous Hinton, Professor Hinton. Now he works for Google. So won the competition in the significant margin. His team reduced the error dramatically, and the task is the image classification with 1,000 categories. And their team uses CNN, convolutional neural networks. And so this is the network. So I'm not gonna explain the detail, but the input is like the pixels of the image, and the output is the category, 1,000 category, like which include cats or dog or the airplane or, and so on. And so we wanna use this network. So I wanted to use this network, and there's some deep learning frameworks, and so we decided to use Caffe, but I think I should say I'm using Theano, but I'm using Caffe. But that's so. Caffe is implemented in C++, but the Caffe has Python binding, so it's okay, I think. And the most important, the Caffe has the pre-trained network. So that means that, and the network was trained with the ImageNet. That means that you don't need to train. So so we can use the word best algorithms or network for free, of course. And yeah, this is the website of Caffe, and they call this page Caffe Model Zoo. So there are a lot of the cutting edge pre-trained networks. So go to this web page and download it, and you can use it. So this is the example. So if you put this image to the network, you can easily get this kind of result. So the top three is the different kinds of cat, that because the network was trained with different kind of cats. So obviously this is a good result, but it doesn't work for the Marsface as a Marsface, Mars object detector. That the reason is that this is not good, the MG result. So the top guess is orangutan. There's no orangutan in the image. So the problem is that the deep learning cannot understand where the cat is, and the cat is really small for the deep learning. So we need something to detect the interesting region so that you can apply the deep learning algorithm. So there are some techniques, and the simple one is called sliding window. So you can slide a window, and you can and in this approach you can get too much too many windows, like because you have to uh, decide the pitch of the sliding or scale of the bounding box or aspect ratio of the bounding box. This is not clever for the deep learning algorithms because the computation it's quite expensive for our analysis. So we have to reduce the number of windows. So we decided to use the algorithms called selective search. This is more clever algorithm, and it gave us a grouping. It give us a grouping parts of image at different scales. So in other words, the more interesting region was proposed by this algorithm, and that's really good for the Mars object detection. And we applied it, and this technique is influenced by the Berkeley vision team, so which create the cafe framework, and this is the result. And you can choose the number of the windows, but this is kind of example of the result of selecting the windows from selective search. And then I applied the deep learning algorithms to each window so that we can get these results. I mean, so the right-hand side of the picture, so all of these windows are classified as a cat, so that you can understand, so that we understand this. So where is a cat? And unfortunately, a selective search was implemented in MATLAB. And as I said, the cafe is implemented in C++, but I think that's great. That's the advantage of Python. And Python is really good to put all together, even though they are implemented in the different languages. So you can, and fortunately, there are Python wrappers, so we use them to find object. I'll share with you some results. This is the first one. This is the happy face creator. This is the famous one actually, and the other, I don't know, people from somewhere find that. I mean manually, but we could find it with these algorithms. And also, we got this result. Wizard? Looks like wizard? No. But it's okay. But it's important for us. I mean, so the original image is much, much bigger. And this, we can find it because of the strong, great algorithms by the selective search, that the selective search proposed the interesting region. And that is one of this one. And yeah, this look like the human face, right? The side face, don't you think? For me, yeah, it looks like the human face, but. And next one is, this is original image. Can you find something in this image? It's hard, right? So obviously, some algorithm is needed. Manual the check is so difficult, but there is. The resolution is not good, but the algorithm found the bird, African gray. That's a pretty good result. And yeah, this is the, I think, best result detected by the deep learning, but we also have some problems. Golf ball. we got a lot of GoFo results, and you know the NASA's image has this kind of planets. So this is something I called GoFo issues for the Marsface project. Okay. So next, so that's the explanation is of the algorithms, and so these are the future works that I would like to work on. So obviously we need more robust segmentation technique. I mean, compared to the selective search. So if you know something great, please let me know. And also, that we would like to. So our classification result depends on the pre-trained network. I mean, 1,000 categories defined by the ImageNet. So we increase the number of objects in the future. And fortunately, we got the IBM award at the hackathon this year, and they offer API to use Watson, and for object recognition. Probably I'm going to try it. And also we just tried a little bit for the crowdsourcing service. I mean, as I explained, this is time consuming. It's really hard to check all the false positives. So we tried the Odesk, something called the website or service called Odesk. It's like, how many of you know Odesk? No, oh, okay. It's like how about the Amazon Mechanical Turk? It's like, so they are a crowdsourcing service. You can ask someone to check, for example, for our project, check the images. So we put a lot of images with false positives on the website, and someone is trying to find it with like $2 or $3 or something like that. And also, we are trying to create something more interesting with satellite images. Okay, I'm going to introduce one more application we are working on. That is called Project Giant Leap. And the name is from the Apple project. Do you know Apple project, Apple 11, which went to the moon for the first time with human. And so one of our members, probably like hardware engineer or maker, came up with the idea of creating something in the intersection of space and Oriental medicine. This is our work. So we did this at this year's hackathon, and this is called Giant Leap, and we created a prototype for the 3D printed Reflexology Sandals. And look at the bump in the middle. So there's a good for your stomachache. And we are still working on it. And also, this is available on the website of the dmm.com. I think and there are some colors to choose from, probably. And also, this is also expensive. And but you have some concern about the size of the sandals. So come visit Tokyo. We are going to have a booth at Maker Faire Tokyo this year. So if you are interested in our project, come join us at the Maker Faire Tokyo. Okay, that's almost done. My presentation is almost finished. That's one small step for man, one giant leap for mankind. Thanks for listening. So you have any questions?
I was a little bit curious about how does the selective search actually work.
Okay.
I mean the procedure and the algorithms. And the other question of mine is that how did you actually correspond the interesting object that your system detect to the picture you show? Did you do it manually because you said that you thought the image looked more like a human face than a lizard? Yes. So, okay.
Okay. So for the first question about the selective search, so I cannot explain the detail of the this, but the algorithm basically choose check the color, different types of characteristics that the image have, like the color of the images or texture of the images, or the paper said that they are checking the exposure or lightning, in other words, lightning of the images, and they and then merge the kind of algorithms to decide the final windows.
Okay, but how did that speed up your calculations?
We cannot speed up the calculation actually,
Um,
but it's not that expensive compared to the deep learning. So it takes like a few seconds to get result. But obviously it depends on your environment. But
okay.
it's not that computationally expensive process.
Also, it's just less expensive than the sliding window method for the deep learning algorithms.
With yeah.
Okay.
And the second question is like, yeah, we did manually. That's the issue we had. So if you have any ideas to solve that, please let me know. So now we check manually.
Uh-huh. I think that's why you need crowdsourcing.
Yep.
Yeah. Okay. Very interesting project.
Thanks.
Have you ever tried to train alien face heart detector?
No, yeah. It's really so we have been we have an idea
Hmm.
for a long time, but we cannot. The one problem is that we cannot collect enough samples.
Uh-huh. And
Yeah,
how?
but so but I have an idea to that it might be good to generate like alien faces.
Roughly how many samples or images are needed for the heart detector?
I'm not sure about it. It
Okay.
depends on the yeah.
Okay.
Mm, it depends, right?
Thank
I
you.
think. Obviously, we wanna if it works well, we wanna try it. Any questions? No?
Hi, Takeshi-san. And I I had a question that you say you're gonna add more data in the future because of the ImageNet is kind of pre-trained and they have specific objects. And if you want to find the real artificial object in Mars, you're gonna add what kind of object, what kind of data you're gonna add into your training data?
Uh, okay. Uh, so there are some one of the famous Japanese publisher contact us and ask to find find a lot of volcanoes or other mountains in the in the MERS, so we have an idea to try that, like volcano shape or other, like sphinx shape or like
Yeah. Yeah.
the pyramid.
Yeah, the pyramid. And
Yeah.
yeah, by the time they found the face, the artificial face, they also find the pyramids and like something like Sphinx.
Yeah, yeah,
Those kind of architecture, those kind of
yeah.
on Mars. So
Yes.
yeah.
Yeah, they are saying that face is enough.
All right.
Yeah, and yeah, say so they asked me to find different kinds of object.
Yeah. All right.
I
Thank you.
think anything interesting is okay
Yeah. Yeah. Thank you.
for our project. I mean. Okay.
It's very interesting research topic. I'm very curious that how did you raise the research fund? Because in Taiwan, when we ask the approval for research, it's always very some boring or serious research topic. So did you raise any research fund for the research project?
So you are asking. So so you are asking how to find funding money for our project, or
In these two interesting topic. Yeah.
interesting topic.
Yeah, in the example you mentioned.
So I think it's important to. So we Marsface project. Oh, okay, just me. Has a lot of members actually, from the different backgrounds, including the engineers, researchers, and artists, writer, or robot, and and that kind of environment. I think that kind of environment create new ideas, and we are working for. So this is not kind of job we are doing. So this project is just for fun. So approval is not needed, right? That's I think and also important. Am I asking you a question?
Okay, I think that's all for today. If you have further questions, welcome to ask Mr. Hideki afterwards. And let's give him a big hand and thank him.